What's up, everybody? This is Mr. Richardson coming at you live through the power of the internet. What we're going to do today is we are going to find out how do we apply normally distributed data to different populations. If you're just tuning in, make sure that you've watched my previous video. My previous video is on how do we use a graphing calculator to analyze normally distributed data. Let's jump right into it. We had talked previously about the high temperature in New York City, and we're going to expand on that knowledge today in a two-part question. Shown below, what you're seeing is the average monthly high temperature for New York City, meaning in April, the average high temperature for New York City is about 61 degrees, while in July, the average high temperature for New York City is about 84 degrees. In the first part of this question, we want to find the percentage of days that the average high temperature in New York City would be below 32 degrees. In the second part of this question, we'll take that information and apply that to finding how many days in a year would we expect the average high temperature in New York to be below 32 degrees. First thing I want to do is calculate the mean and standard deviation based on this data. We have done that before in a previous video. What we found was that the average high temperature for New York City is 62 degrees with a standard deviation of 16 degrees. What we can do is apply that data to a normal distribution curve. First thing we do is place the mean below 0. Then we use the standard deviation of 16 to count one standard deviation above, and so on. 62 plus 16 would be 78. And we continually keep adding 16 degrees just to fill in some of this information. We could do so as well with the information below, subtracting 16 from 62. Using this information, we already learned that 68.2% of the data sits within one standard deviation of the mean. So what we would know for this is that approximately 68.2% of the days have a temperature, or an average high temperature, between 46 and 78 degrees in New York City. But we're not interested in how many days fall between 46 and 78 degrees. We're interested in less than 32. Well, here's 30, so 32 must be somewhere about right here. This here shows the percentage of days that are below 32. Because the temperature falls within a standard deviation line, we're going to have to use our Normalcdf formula, which we learned about in the last video. We want to know less than 32, so we don't know what the lower temperature is. We want it to go on forever to the left. So we're going to input the left value as something really small. Here we'll pick negative 999,999. The right value we know is 32. That's the highest temperature that we want. The mean we know is 62 degrees and the standard deviation is 16. We plug this in the calculator and it gives us this. This is the decimal version of the percentage of days that the temperature is less than 32 in New York City. To make it a percent, simply multiply by 100. And of course, let's round this to the nearest percent. This is about 3%. What that means is that if you live in New York City, you can expect the temperature to be below 32 degrees 3% of the time. Now we want to apply this to the population. In this part, our population, what we're referring to is the number of days. We want to know how many days in a year would you expect the average high temperature to be below 32 degrees in New York City. Well, if you think about how many days are in a year, there is going to be 365 days in a year, and we know that 3% of those days will be less than 32. So what part B is really asking you here is it's really saying, what is 3% of 365? So what I'm going to do is I'm going to take the decimal representation of the percentage and I'm just going to multiply it by 365 days. This is essentially going to tell me what is 3% of 365, or in reality, how many days do we expect the high temperature to be less than 32 degrees? When I take that product, we get 11.09, and rounding to the nearest day, we could say that this is 11 days. What does that mean? That means that in New York City, 11 days of the year, the temperature should be below 32 degrees. Let's see if you can try one of these on your own. In this problem, we have the scores of a recent test taken by 1,200 students, and they're approximately normally distributed with a mean of 225 and a standard deviation of 18. Here, determine the approximate number of students who scored between 200 and 245 on the test. First thing I like to do is just draw a blank normal distribution curve to center the work that I'm going to do. I always take the mean and place it below 0. In this case, the mean is a score of 225. Now I use the standard deviation to go above and below to kind of complete the curve. Well, a standard deviation here is 18, and if I add 18 to 225, I get 243. I can also subtract that standard deviation from 225 to get the following values. Now, I want to know what percentage of data is between 200 and 245. Well, that's going to be about here. I can see that this is a very large percentage of the data by how much of the curve was shaded. Now I'm going to use my Normalcdf formula. My leftmost value that I want to compute is 200. My rightmost value is 245. The mean is 225, and the standard deviation we said was 18. Calculating this, I get this number here. What this means is that on this recent test, about 78% of students scored between a 200 and a 245. But that's not what the question asked. They didn't ask what percentage of students scored between 200 and 245. They asked how many students. So what I want to do is take this decimal representation of the percentage and multiply it by the population. The population here that we're talking about is this 1,200 students. Multiplying these two numbers, I get about 941 students. What this means is out of the population size of 1,200 students, about 941 of them scored between 200 and 245. Let's try another example. In this problem, we're going to talk about the average daily high temperatures in San Francisco, and we learned earlier that that temperature is about 64 degrees with a standard deviation of 4. Use this information to determine the number of days in a year in San Francisco that would have temperatures between 65 and 70 degrees. First thing you're going to want to do is draw your normal distribution curve. A little sketch here will do. Place the average below 0, since it is 0 standard deviations away from the mean. Now use that standard deviation of 4 to place some numbers above and below the mean. Here we want to find when is the temperature going to be between 65 and 70 degrees. So that's going to be about here. A nice percentage of data, but certainly much less than 50% of the data, as the mean here cuts off where half the data is. I'm going to bring up my Normalcdf function. Plug in the leftmost value. The leftmost value here is 65. The rightmost value is 70. The mean is 64, and the standard deviation is 4 degrees. Plugging that in, I get 0.477249. What this means is that in San Francisco, the average high temperature will be between 65 degrees and 70 degrees about 47 or 48% of the time. But that's not what the question asked. It said, in a calendar year, how many of the days would be between 65 and 70 degrees? So I need to take this number and multiply it by the population, which in this case is 365 days. When I do that, I get an answer of about 122 days. Maybe that's a lot of the allure of living in San Francisco, is that 122 days of the year, you're going to have really nice, comfortable temperatures of between 65 and 70 degrees. Let's try another example. This problem reads that there are 440 students at Brooklyn Tech High School enrolled in chemistry. On a February report card, the students' grades are approximately normally distributed with a mean of 79 and a standard deviation of 7. Students who earn a grade of less than or equal to 64.9 must attend summer school. The number of students who must attend summer school for chemistry is closest to. First step is to draw a blank normal distribution curve. Take the mean and place it below 0, and use the standard deviation of 7 to find numbers above the mean, and also subtracting it from 79 to find numbers below. In this case, we want to find the percentage of students who earn a grade of less than 64.9. That's going to be this very tiny region here. In order to do this, we're going to have to use our Normalcdf formula. First thing we want to plug in is the leftmost value, which we don't know. We want all of the grades that are less than 64.9. You could assume that the lowest grade a student could receive is 0, but to make it uniform, when we don't know a left value, we always just input negative 999,999. The right value here is going to be 64.9. The mean we can see is 79, and the standard deviation is 7. Calculating this, I get about 0.021. What this means is that only 2.1% of the students earns a grade of less than 64.9. We want to find out how many students have to attend summer school. So I take the population, which is 440, and I multiply it by this number. When I do so, I get about 9.67, which means that approximately 10 students will need to attend summer school for chemistry. Let's try one final problem. This problem is about a study of 82 video game players who participated in a gaming tournament. Researchers found that the ages of these players were normally distributed with a mean age of 17 years and a standard deviation of 3 years. Use this information to determine if there were 18 video game players in the study who were over the age of 20. Justify your answer. In order to answer this question, I'm going to have to do a few things. First, I'm going to have to find the percentage of players in this study over the age of 20. Then I'm going to have to multiply that percentage by the 82 video game players in the population, figure out how many they were, and then compare it to the 18 that they're asking, was there 18 players? So let's do just that. First step is to set up my normal distribution curve. I'm going to place the mean below 0, and I'm going to use that standard deviation of 3 years to find numbers above and below the mean. Here I want to know if there was 18 video game players in the study over the age of 20. So let's find the percentage of video game players over the age of 20. That would be this region here. Bring up your Normalcdf function. My leftmost value is 20. That's as young as we want to analyze a player here. The right value we don't know. When we don't know a right value, we always fill in 999,999. The mean is 17 with a standard deviation of 3. Figuring this out, I find that there's about 15.8% of the players are above the age of 20. If I know that there's 15.8% of the players over the age of 20, I really want to know, well, how many players are over the age of 20? So I take that number and I multiply it by the 82 players in the population. What I find is that there should be about 13 players that participated in this gaming tournament above the age of 20. Now I can answer the question they wanted to know, determine if there were 18 video game players in the study over the age of 20. No, there is not 18 players over the age of 20 in this study. By our calculation, we predict that there should be about 13 players over the age of 20. Thanks so much for tuning in to watch this video. I hope you learned how to take a normal distribution curve and apply it to different populations. Until next time.